it's always a conversation. So, okay. 2.5 deals with transformations. I want to have enough time for these sections because these are most probably totally new to you. So that's why I needed more time for this. But again, if you find something, stop me and we'll take a break from this and we'll come back to it. Okay. When we looked at functions, we determined a lot. Domain, range. Now we know max, min. Increasing and decreasing intervals. Finding values, evaluate. And so on and so forth. We're going to add something called transformations. Now, can I understand the function without transformations? Yes. Are transformations crucial? No. But like finding max, min, finding increasing, decreasing, evaluating a function, this is a characteristic of a function. So knowing transformations gives us a better insight in how or what this pattern means. Now, transformations mean nothing if we do not know and remember basic functions. If I don't know and don't understand the graphs or remember the graphs of basic functions, I can never apply transformations, or I can never understand what transformations were applied to the basic functions to create more complicated functions. So first of all, we need to list the basic functions and their graphs, and then we will understand how transformations are applied to basic functions to create more complicated complicated graphs, complicated functions. So first, we start with a basic linear function. What do I mean by basic? The simplest possible function from each category. What is the simplest function in the category of linear functions? It's f of x equals x. Because if I have 2x plus 5, it's not the simplest. If I have 1/2 x minus 3, it's not the simplest. All these are linear functions, but they are not the basic one. This is the simplest possible linear function. And moving forward, we need to remember its graph. So I did add dot here, but remember odd and even. That's another very important property. Can I live well without knowing which function is odd and even? Yes, we can live very well without knowing which function is odd or even. But it's a property of the function. So we should understand the property. We should be able to identify if a function is odd or even. If it has a max or min. In other words, if it's symmetric, if it has max, min, if it's increasing, decreasing. All these things tell us something about the function. And we will be better equipped to read functions from graphs and from other situations. Okay, so now I need to graph this function. Please remember, this is it. It's the function it's the line that bisects the first and the third quadrants. So this is y equals x. Is this function odd, even, or none of the above?
Even.
Yes. No. It's symmetric. This is symmetric with respect to the origin. Even functions are symmetric with respect to the y-axis. So this is odd. But perfect. Moving on. So this is the simplest possible linear. Now let's look at the simplest possible quadratic. Second category, quadratic. Can anyone identify which is the simplest, the basic quadratic function possible? If the basic linear was x, what can the basic quadratic be? What do you think? Can anyone give us the basic quadratic? What can it be? Anyone, please? It's okay if you're wrong.
Ax squared plus bx plus c equals 0.
That's it. That is it. If the basic linear is x, the basic quadratic is x squared. Nothing. Clean, plain, nothing. Good. We have to remember its graph. The plain, simplest quadratic is this. So this is y equals x squared. Odd, even, or none of the above?
Even.
Excellent. Excellent. Perfect. Third category, absolute value. Can anyone give us the simplest possible absolute value function?
Absolute value x.
That's it. Plain. Good. Here's the graph of the absolute value of x. We also call it a v function. The v function, y equals the absolute value of x, odd, even, or none of the above? Odd,
Neither.
odd, even, or none of the above?
Would it also be even?
Of course. What I have in this quadrant, maybe my graph is not perfect, but what I have in this graph, in the first quadrant, I have in the second. What I have in the first, I have in the second. Good. Category number 4, square root. Can anyone give us the simple, basic square root?
Is it just square root of x?
That's it. Absolutely. Nothing else. Basic. Okay. Can anyone give us the domain? I didn't ask you for the domain for the other ones. It's all real numbers. But can anyone give us the domain for this one? We discussed the domain of the square root several times. Anyone, please? What is the condition for the square root to exist? please. The square root exists only. What can we take the square root from?
One.
Yes, what else? What did we say that the square root exists for? What can x be? What should x be for the square root to exist? Hunter, do you remember?
Would it be x squared?
No. Shay, do you remember? Imani, do you remember? Are you with us? Okay, let me go back to that lesson. Very important to remember. We looked at the radicals with even indices and odd indices. Yes, sorry.
To the half power.
To change it into x to 1/2, yes, but we're asked to find the domain.
Okay.
That's correct. It's the same thing. The square of x or x to 1/2 is the same thing. But we want to determine the domain. This is very important to remember. I don't remember which lesson it was. It was not August the 25th. Maybe it was August the 27th. No, it was not August the 27th. The September the 3rd. Here it is. So what is the domain of the square root of x? Please. What is the domain of the square root of x?
Zero.
The domain. The domain.
0 to infinity.
Correct. The domain is indeed 0 to infinity. We can, if you ask me to plug in any number between 0 and infinity, I will give you a number. But if you ask me to plug in -5, I will not be able to give you a number. So please remember this, because that's where the graph will exist. And here's the graph. This is not a straight line. It's a little bit curved. So this is y equals the square root of x. Please remember, this is a very important function. So now, can anyone tell us if this function is odd, even, or none of the above?
Odd.
Odd has to have symmetric. Whatever is in the first quadrant has to be in the third. Or whatever is in the second has to be in the fourth.
None of the above. Neither.
Exactly. Not symmetric. Okay, here's one more. 5. Cubic function. What do you think? The simple cubic function. What do you think is going to be? We never talked about cubic functions, but I was expecting somebody to say x to the third. That's it. Simple cubic function. So here's the graph for the cubic function. We're going to study it in chapter 3. Notice one thing. I didn't graph the x-intercept like this. I graphed it smoothly. It's only one, but not like this. So this is y equals x cubed. I'm emphasizing this because we're going to talk about it in chapter 3. The way the function crosses the x-axis. There are different ways. So this is a different way than what I just erased. Okay, so this is x cubed. Odd, even, or none of the above?
Odd.
Excellent. And one more, promise, the last one. Category number 6. Since we had the square root, we will also have the cube root. And then we can start talking about transformations. The cube root function. Can anyone give us the simplest basic cube root function?
The cube root of x.
That's it. Nothing else. Here's how it looks like. And yes, we have to remember those graphs. Something like this, but on the x-axis. Something like this. This looks like the square root, but it's flatter. Also here, it's not like this, so it's a little bit good. So y equals the cube root of x, because the domain is everything. Let's go back for a second. Here it is. The domain of the cube root is absolutely everything. No restrictions whatsoever. Odd, even, or none of the above? Odd, even, or none of the above?
Odd.
Odd indeed. Good. Let me look at the time, and okay, I'll be quiet for 10 minutes, promise.